Welcome to Education Program Online. This is Teacher Christine taking you in mathematics for Senior 3 and Senior 4. So dear learners, our previous lesson was on limits, and we are still continuing on the same limits, but now today we are looking at limits of constant. Limits of constant. So this is where we are picking from. Yesterday or the previous lesson, we are looking at limits of the basic principles of limits, where we say the limit simply means a problem, and when it is a problem, it means it blocks you from achieving your dream. And if such a situation occurs on your way, then we need to set principles. The principle that will help you or governs or helps you to pull you out from that problem. And then now today we want to look at limits of constant. What do we mean by limits of a constant? This is where we find that dealing with the a constant or innocent values, or values without a variable. Values without a variable. So I think you have ever experienced a situation where someone can just decide to create a problem on you when you are totally innocent. That is where we say limits of a constant. So we say, if we decide to say take C to be a constant, take C to be a constant, then lim of C when x is approaching to A equals to C. A simply means any real number. A means real, any real number. Any real number. So learners, when we say a limit of a constant, we simply express it as lim C when x approaches to A equals to C, meaning that if x approaches to any real number and the number that has been given to you is completely does not carry any variable, then we say this one is a constant. It does not carry any variable. So your answer will also remain a constant, because after you have tried to forge a problem to somebody, or anything that is not right to someone, and when it is approved or followed or investigated, they will still come back that this person is totally innocent. So that's why we say lim C when x is approaching to A equals to C, taking A to be any constant. Either A can be any real number like 1, 2, or 3. No matter it is A approaching to any number, your answer remains, the outcome will be still that very constant. So let us look at the examples. So they will simply say, example, and say find the following. Find the following. Find the following. A lim 5 x is approaching to 2. B lim lim 10 x is approaching to negative 3. Negative 3. So, for example, if we are asking, if you come across this kind of questions, you find that they have said, oh, evaluate this. Lim 5, x is approaching to 2. So, it does not matter where x will approach or where x will go, proceed. But what matters, what is given, what is the function given. So, the function here is a constant, meaning it does not carry any variable. And if it does not carry any variable, what is your answer? Your answer remains a constant. The same thing with this. No matter even here, it is approaching to a negative. So in the common mistakes learners always do, when you look at, because when they say lim, you carry the x, the value of x, and you multiply with the constant, it will give you a wrong answer. Because this x, it is not represented on 5 here on a constant. So your answer will be only the constant. So when we come to our solution, we simply say, you look at your solution, you say A is lim 5 when x is approaching to 2. Remember here in our expression here we say lim C, x is approaching to A equals to what? Equals to C. So our answer here will be, answer is 5. Our answer will be just 5. So you don't need to multiply or to again to look for any other answer outside that. Then part B, say lim x is approaching to negative 3 and here is 10. Then our answer will be 10. You just remember our expression, which is lim C, where C represent any constant number. So our C here in these examples for A, C is the same as 5, and in part B, C is the same as 10. So that is our answer. Then now when we look at the example 2, I will say find the following. Find A lim x is approaching to 1 or 4x plus 3. And then we have B lim x is approaching to 2. X is approaching to 2. Then we have x square minus 2, close the bracket, and then we have x plus 2. X plus 2. And then C, you say lim x is approaching to what? X is approaching to infinity. X is approaching to infinity. X plus 1. X plus 1. So, dear learners, in case you are given to find the values of this kind of questions, what do? You simply look at the question, the equation given. So for the example here for part A, they have said lim, the value of x is what? Is 1. X is approaching to 1. That means x is 1. And then here it contains, this is a linear function. It contains x. And therefore, if it contains x, then it has a slight different from this example 1. From example 1. So, what do? You have to substitute the x with the value of x. And then when it comes to part B, they have given you in form of a multiplication, which contains the two factors. So if we are to also to find the lim of that, then you also had to build a bracket by a bracket before you open it. So let us look at our solution, and we see solution. Part A. Part A, we say lim x is approaching to what? Is approaching to 2, which is 4x plus 3. So since we know that this is x is approaching to 2, then it is the same as to say we shall have 4 times what? Times 2 plus 3. So this will give us 8 plus 3, which will give us 11. So our answer will be 11. So this is your answer for part A. And then now when we come to part B, so part B, we simply say lim x is approaching to 2, which is x squared minus 2x. Close the bracket, and then we have x plus 2. So for this case, learners, you are to don't rush and do what? Open the bracket first. What you do, because this you are dealing with the limits, what you do, handle a bracket as independent, handle each bracket separately before you open them out. What I always say, before you open this bracket out, see what is inside there. Is it well organized or not? So since here is not organized, so make it organized first before you open the bracket. Then now, how do you make it organized? You simply say, I will now have this x is the same as what? Is the same as 2. So you will have open the bracket, 2 square minus 2, close the bracket, times 2 plus 2, close the bracket. And then now from here, when you square 2, we get 4. So 4 minus 2, and then 2 plus 2 will give us 4. So when we simplify here, we get 2. We remain with 2. So you will have 2 times 4. 2. Then at this level, you can now open your bracket by multiplying the two numbers or the two factors. So you say 2 times 2 will give us 8. So our answer here will be 8. So learners, as simple as that. That is how you handle this kind of equations of limits. And then now we look at part C. Part C says lim x plus 1 when x is approaching to infinity. So infinity means it has a start but no end. So if something is continuing, we don't know where it is end. Now what do you think will be your answer? So your answer will also be infinity, because you don't know what is the value of x, where is x stopping, and therefore in this case our answer will be infinity. Our answer will be infinity, because x, which is infinity, plus 1 still will give us infinity. So that is your answer. So don't get confused in that stage. Or you will simply say, I will have lim x approaches to infinity is the same as infinity plus 1, which will give me infinity. So that is your answer for part C. So dear learners, after seeing those examples, we can move to example number 3. Example 3. So example 3 says, if x, this is example 3. If x, if lim of a function x, when x is approaching to 3 equals to 7, find a lim f(x) minus 4 when x is approaching to 3. And then part B, we have lim 2f(x) minus 5 when x is approaching to 3. And then lastly C, we have lim f(2) x when x is approaching to 3. So dear learners, look at this example number 3. Example number 3 says, if lim of a function x equals to 7, so function f is fx equals to, the value is 7, and then x is approaching to 3. And when you come to the equations here, you find that x is a constant, in every equation. So part A, they say the lim x is approaching to 3, which is a function of x minus 4. And then B, lim 2 into a function of x minus 5. And then lim f(2) of x when x is approaching to 3. So if we are to find out this, then remember yesterday we said that watch out the where x is approaching and the type of the equation or the function given to you. Is it a linear, or is it a quadratic, or it is a constant function? So for this case, we find that our function here is a constant one. It does not carry any variable. Therefore, if we are going to attempt these questions, you also have to go in hand with what is given to you. So we come to our solution. So our solution, we say solution for part A. Part A is lim x is approaching to 3, which is fx minus 4. So we know that you come to your question here, the body of your question here, they say the function which is given is 4, 7. That means the whole of fx is what? Is 7. Then you can straight away go and substitute. You substitute that f of x. F of x is given as 7. And then minus what? Minus 4. Which will give us what? 7 minus 4, we get 3. So our answer here will be 3. Our answer there is 3. Then we move to part B. So our part B, our part B, it says lim f this. Remember in our previous lesson when we are introducing lim, we said there are two types of limbs. There's one where we find a constant comes after lim. What does it mean? We said it means you failing to take the advice and then you regret for yourself. And then if this before, it means advice is for the whole function. But since 2 is outside the whole function, then it means that you are going to multiply 2 times what? Times f of x. Then you say lim x is approaching to 3, which is 2 fx minus 5. So when we substitute this, we simply know that our function fx is given as 7. So you will have 2 into what? Into 7, and then close the bracket, minus what? Minus 5. So when we open the bracket here, we get 2 times 7, we get 14. Then we say 14 minus 5, we get 9. So our answer is 9. So that is how you simply answer that question. And then when we come to part C, so part C says lim f square of x when x is approaching to 3. So what does it mean? It means that you are going to square the value of the function given. So our value of a function is 7. So where there is f, we are going to put 7 square. So this will give us 7 square it. So when we square this 7, we get 7 times 7, which will give us 49. So this is our answer. So dear learners, within the concept of constant, limits of a constant, I believe you have picked something from these 3 examples. So you should be able to know, if I'm asked to find any limb of a constant, what should I do? And if I'm asked to find a limb of a composite function, what should I do? So this is what we have been looking at. So with this, I believe you have picked something, and I want you to take these questions as your exercise. So you say find the following. Find the following. A limb 1 when x is approaching to 5. When x is approaching to 5. B, we have limb x is approaching to 0. X is approaching to 0. We have 5 minus 4x. And then C, we have limb x is approaching to 1. X is approaching to 1. We have 2x minus 1. And then x minus 2. D, we have limb when x is approaching to infinity. We have 2x square plus 4x plus 1. And then number 2, he said if fx equals to 5 when x is approaching if lim x is approaching to infinity, x is approaching to 0, x is approaching to 0, find a lim fx minus 3, x is approaching to 0. And then we have b lim f cube x is approaching to 0. So dear learners, I want you to take those questions and you try to answer them following the examples we have seen. And then I hope that with this you have picked something especially on the limits of a constant. With this, we have come to the end of our lesson for now, and I wish you the best. Goodbye.